This video is about functions. Remember what functions are? Sometimes it's best to do it with an example. The first function I'm showing here is a chart of values showing how my puppy Shadow grew in the first 4 weeks we had him. He was 7 weeks old when he arrived. The X values that you see here go from 0 to 28. They're measured in days. The Y values are the actual weight in pounds. You'll probably remember that we consider the X values the independent values. And they're usually pretty boring, like time or the days in this case. The Y values are called the dependent values, and they're the story. That's why we call it Shadow's weight. Shadow's weight is measured in the Y value. So each point on this function tells you at a certain number of days that Shadow was in our house, what did he weigh? The other thing I want to remind you of, we consider the X values to be defined on a domain. That tells you all the X values that are allowed. In this case, the X values have to be greater than or equal to 0 because Shadow couldn't be in our house a negative number of days. And the Y values here are greater than or equal to 12 because Shadow started out at 12 pounds. The Y values are the possible values that can be generated, and that's called the range. So again, the domain are the independent variable values and the range of the dependent variable values. So the question is this a function and how do we know? Sometimes it's best to consider an example that isn't a function. So suppose we did the same thing, and instead of having every day we have a single weight, we had some confusion. On the 21st day, Mom weighed Shadow and got 20.5 pounds. And just after Mom finished, Dad weighed Shadow and got 25 pounds. It could be that they wrote the number differently. There's a 2 and a 5 in both, or that they read it differently. But there are two values here. And when you graph it, you can see there's a confusion. There's actually a vertical line. Because on the 21st day, X equals 21, we have two possible weights. This is not a function. Whenever you see a vertical line, or a vertical line can connect 2 points, you know that you do not have a function. Keep in mind that functions refer to situations where it actually makes sense that each X value has one Y value. So in the case of this function I'm showing you, it doesn't make sense for Shadow to have 2 weights on the 21st day. It makes sense that he has 1 weight on every day. There are other functions like this, birthday functions. If the people are the X values, each person has a different birthday, or I should say a single birthday. They might all have the same birthdays, but they each have 1 birthday. Now suppose Shadow's cousin Coda comes and we weigh him for 5 days. But Coda weighs the same thing every day because Coda is full grown. That gives you a horizontal line. When X is 1, we get 27. When X is 2, we get 27 pounds, and so on. And this is also a function. It's a very simple function, but it makes the point that all the X values can have the same Y value. They just can't have more than 1 Y value. All right, now we're going to just look at some functions you should be familiar with. This is not that you should memorize them, but you should know the names and you should know some of the features that I'm going to mention here. That will help you in your study of graphs or your study of calculus or your study of pre-calculus, whatever it is you're doing with graphs. Okay, so the first graph we have should be very familiar. This is a parabola, y equals x squared. We say that this is a second-degree function, and that degree comes from the fact that it's x to the second power. The degree is usually the highest power of x that you see in the function. It's a polynomial of degree 2. The next one that I'm showing here is a cubic. It's one of my favorite cubics. Y equals x cubed minus 2x squared. And this is a polynomial of degree 3, and again, you see that the highest degree is 3, and that's why the degree of the polynomial is 3. Okay, let's leave polynomials for a bit and look at a trigonometric function. Trigonometric functions are characterized by repeating patterns. You can look at what happens. We go up, we go down. When we return to 0, we start the whole thing again. This one happens to be y equals sine x. Trigonometric functions repeat. They have amplitude, how high they go, how low they go, and they have a period. How long does it take them to produce one of the single patterns that it uses? So this up down is the sine pattern, and it goes from 0 to 2 pi. Okay, the next function here is the logarithmic function. This one is y equals the natural log of x. What characterizes this function is it is so very slow. Between 0 and 1, it increases very quickly. But after that, it gets slower and slower and slower. And way out here, it looks almost horizontal. It's always increasing, but it's the slowest increase you can imagine. In contrast, actually it's inverse, we have exponential functions, y equals e to the x. Exponential growth is fearful growth. Exponential growth characterizes how credit card debt grows. Exponential growth characterizes how dangerous pandemics grow. Exponential growth, unless it's the interest rate you're getting, which almost never happens, exponential growth is to be feared. In later videos, we're going to look at how to describe the behavior of each of these functions.